Hello students, today we are going to discuss about network layer. That's a chapter 4 of module 3. Basically network layer, which comprises of few of the topics like network layer services, which includes packetizing, routing and forwarding and other services. And also we will be discussing about packet switching, the different approaches of packet switching like datagram approach, virtual circuit approach. And regarding the network layer, we will be discussing about IPv4 addresses, different types of addresses, that is addressing methods, classful addressing, classless addressing, and network address resolutions. Okay, and how basically the IP packets are forwarded based on their address and the label. Okay, so these are some of the topics which we will be discussing. To proceed further, basically the network layer in TCP/IP protocol suite, it is responsible for like host-to-host delivery of datagrams. Okay, and it provides services to the transport layer, and it receives services from the data link layer. Okay, so what are these network layer services? Okay, before that, analyzing about the services of network layer, let us have a diagram which depicts how basically the network layer is involved at the source, host, destination, and all other routers which are existed in the path of communication. Okay, so this is the diagram which gives some information about the communication at the network layer. Although the source and destination hosts are involved in all the 5 layers, okay, of the TCP/IP protocol suite, the routers use the 3 layers, that is physical layer, data link layer, and network layer, if they are routing packets only. Okay, and router basically as shown in the figure with 2 data link layers and 2 physical layers, because it receives a packet from one network and delivers it to the another network. Okay, so both encapsulation and decapsulation takes place at the network at the router. Okay, and there are few of the services which are provided at the network layer. So one by one we are going to discuss here. That is, one is packetizing. Basically what happens is encapsulating the payload. Okay, what is the data which is received from the upper layer in the network layer. Okay, that network layer packet at the source, and decapsulating the payload, okay, from the network layer packet at the destination. Okay, so this is the basic concept of like packetizing, and it is as good as like the network layer service, such as like postal office. You can take an example of a postal office which is responsible for delivery of the packages from a sender to a receiver without changing or using the contents. Okay, so that is the concept of packetizing. Basically here what I just told you is encapsulating the payload, okay, in the network layer packet at the source, and decapsulating the payload from the network layer packet to the destination at the destination. Okay, basically here the source host receives the payload from an upper layer, okay, protocol, adds a header that contains the source and destination address, and delivers the packet to the data link layer. Okay, the basically the source is not allowed to change the content of the payload unless it is too large, okay, for delivery, and needs to be fragmented. And the destination host receives the network layer packet from its data link layer, decapsulates the packet, and delivers the payload to the corresponding upper layer protocol. If the packet is fragmented at the source or at the routers, okay, along the path, the network layer is responsible for waiting until all the fragments arrive and reassembling those packets and delivering them to the upper layer protocol, okay, or upper layers. Now the routers in the path are not allowed to decapsulate the packets as they received unless the packets need to be fragmented. Okay, and the routers just inspect the addresses for the purpose of forwarding the packet to the next network on the path. And to talk about routing and forwarding, basically routing, the network layer is responsible for routing a packet from its source and source to the destination. Okay, so a physical network which is like you can call it as an LAN or WAN, okay, and routers that which are connecting them, okay, that you can consider as a physical network. And the network layer which is responsible for finding the best one among these possible routes, okay. So which is basically run no which is basically done by running some of the routing protocols. Basically these routing protocols help the routers to coordinate between their neighborhoods, okay, to come up with an consistent table so that they can find a proper path when the packet arrives. And these routing protocols that should be run before any communication occurs, okay. And I told you about forwarding, how forwarding occurs. Let me show you with a block diagram here. Okay, this is the process of forwarding. Basically forwarding, you can define it as an action which is applied by each router when the packet arrives at one of its interfaces, okay. So there will be a routing table or a decision making table at the router, basically that normally uses, okay, for applying this what we can say, forwarding the path, okay, forwarding the packets using the routing table, okay. So when a router receives a packet from one of its network, it needs to forward that packet to another attached network, okay. Sometimes like you can call it as an unicast routing, or it could be a multicast routing, because it may not be necessary always that you have to go with a particular routing, because as I told you in the previous classes, there are different type. The destination can be unicast routing, multicast, or even it can be a broadcasting, okay. So to make this decision, okay, the router basically it uses the pieces of information in the packet header, which can be the destination address or it could be the label, okay. To find the corresponding output interface number, it looks up the forwarding table, okay. So this is how the process actually happens. Once it sees the forwarding table, and it will see that which is the interface that is connected to the particular sender or a particular station, okay, and it forwards that to the through that particular path to the different networks, okay. Now let us talk about some other services which are provided at the network layer, that you can call it as an error control, okay. So error control, the designers of basically the designers, okay, they have added a checksum field, that is CRC field, what you call it, a cyclic redundancy check, okay. So this field which controls basically any corruption or corruption which happens in the header, but not in the whole datagram. Actually the checksum may prevent any changes or corruptions in the header of the datagram. And the internet basically it uses an auxiliary protocol. I told you that is ICMP. When you previously studied, we have come to know that there are different types of protocol, ICMP, IGMP, okay. So here internet basically it uses that auxiliary protocol ICMP, and that provides some kind of error control if the datagram is discarded, okay, or has some unknown information which is in the header, okay. So that is how the error control can be checked in this particular process. And regarding the flow control, that is also one of the services which has been provided at the network layer. Flow control, it regulates the amount of data a source can send without overwhelming the receiver, okay. If the upper layer at the source computer produces data which is faster than the upper layer at the destination computer, okay, the receiver will be overwhelmed with the data. Now how to control that? Okay, to control the flow of data, the receiver needs to send some feedback to the sender to inform that it is overwhelmed with the data. Okay, the network layer in the internet basically does not directly provide any such flow control. Okay, few reasons for the lack of flow control in the design. I'll just let you know what are those reasons. Okay. Okay, so these are the few reasons which I have listed here. Basically in the design of a network layer, that can be considered as basically first one is there is no error control in the layer, okay, and all this job, okay, is has to be As there is no error control in this layer, because the basic job of an error control, flow control, which is dealt by the data control layer itself, so there is no error control in this layer. The job of the network layer, the receiver, is so simple that it may rarely be overwhelmed, okay, because all these services, probably it is taken care at the data link layer itself. And the upper layer, that basically it uses a service of the network layer that can implement the buffers to receive data, and they do not have to consume data as fast as it is received, okay. So that is also one of the reason that there is a lack of flow control in the design of a network layer. And basically flow control is provided for the upper layers protocols that use the services of the network. And another level of flow control makes a network layer more complicated, and the whole system becomes less efficient, okay. So these are the few reasons which you can just consider as points for lack of flow control. And next, let us move on to the congestion control. Congestion control, basically, if the number of datagrams sent by the source computers is beyond the capacity of the network or routers, okay. In that situation, some routers may drop some of the datagrams, so we need to take care of this datagrams which are being lost or dropped at the destination, okay. So however, as more datagrams are dropped, the situation may become worse, okay. So due to the error control mechanism at the upper layers, and the sender may send duplicates of the lost packets, okay. So if congestion continues, then the situation may reach a point where system collapses and no datagrams are delivered, okay. So the last service that you can consider is a quality of service. Basically, as the internet has allowed new applications such as multimedia communication, okay, which includes the audio, videos and other things, the quality of service of the communication has become more and more important. And the internet, basically, it has thrived by providing the better quality of service to support these applications, okay. And security is also one of the parameter you can consider. The network layer was designed with no security provision earlier. Now today security has become a big concern, because to provide the security for connectionless network layer, okay, we need to have another virtual level that changes the connectionless service to a connection oriented service. And that virtual layer, you can call it as IPsec, that is IPsec. Next, let us discuss about switching types, that is packet switching, circuit switching, okay. Basically, regarding the packet switching, there are two different types of switching, that is circuit switching and packet switching. And if we talk about a router, it's a switch that creates a connection between the input and the output port. Here, in case of packet switching, the network, it's like it is used at the network layer, because the unit of data at this layer is a packet, okay. And circuit switching is mostly used at the physical layer, because the information will be sent in terms of bits, that is ones and zeros. So you can just consider circuit switching at the physical layer. Now the connecting devices in the packet switching network still need to decide how to route the packets to the final destination. Now today, packet switch network can use different approaches to route the packets. That is, there are two different approaches you can consider. One is datagram approach, other one is the virtual circuit approach. Now how does basically this datagram approach works, okay. So basically this is the connectionless service. Here the network layer protocol basically treats each packet independently, and they are having no relationship with each one another, okay. And in this type of approach, the packets in a message, they may or may not travel in the same path to the destination. A packet may followed by another packet coming from the same or different source, okay. And each packet is routed based on the information contained in its header, source and destination addresses. And the destination address defines where it should go. The source address defines where it comes from, okay. The router in this case basically it routes the packet based only on the destination address. The source address may be used to send an error message to the source if the packet is discarded, okay. I hope you have all understood about the datagram approach, and it is a connectionless service, which is a type of packet switching, okay. And the next approach is virtual circuit approach, which I will discuss in the next session. Thank you all.